Assalamualaikum warahmatullahi wabarakatuh. So now we continue on chapter 5, Arithmetic Circuit. This is the outcome for chapter 5. At the end of the lesson, the student should be able to perform the binary addition, construct the half adder, full adder and parallel adder circuit, differentiate between sign number and two complement numbers, perform conversion of sign and two complement numbers, perform the two complement arithmetic, and the last one, construct the subtractor and adder subtractor circuit. For our first lesson, we only concentrate for perform the binary addition and construct the half adder, full adder and parallel adder circuit. We start with the binary addition. So how we can perform the binary addition? So actually, binary addition can be performed as the same way as decimal addition, except the value that we are using is actually value 0 or 1. Okay, so example, addition of 1 bit. Okay, addition of 1 bit involve 4 possible combinations. So this is a 4 possible combination. Okay, 1 bit meaning that each variable represent by only 1 bit. A 1 bit, B also 1 bit. So this is the format, the process of addition for 1 bit. So we only have A, B, S as your sum, and then C as the carry. So this is example of addition. Okay, for example, if A value is 1, B is 0, so 1 plus 0 you will get 1 as your sum, and then you have carry equal to 0. So for the last one, A1, B1, so 1 plus 1, S is 0 and carry is 1. So meaning that 1 plus 1 you will get 1 0, okay, or 0 1. When we add larger number that have multiple bits, okay, so we need to add each pair of bit with the C in. Okay. So this is the format how you can add multiple bits. For example, if you have 4 bits, meaning that A have 4 bit, B also have 4 bit. For example, for this value, okay, A 4 bit, okay, which is 13 in decimal, and then B is also 4 bit, which is equal to 6 in decimal. Okay. So this is how you perform the addition. You need to add each pair. So if you look at this format, the first column only have 2 bits. Okay, the first bit of A and B, and then you will get S1. Okay. And then the next one you have C in. So C in is actually comes from CO. Okay, A plus B you will get S1 and also CO. Okay, because we have column, okay, next, okay, with the A1 and B1, so that's why this CO need to carry to the next column. Same goes with the next column, okay, except for the last column, which is this column, okay, because there is no value, yeah, next column, so that's why you just put CO value here. So this is the process of addition. Yeah, process of addition. So this is the value of A, this is value of B. Okay, so A is 13, okay, B is 6. Okay, so this is 13. 13 plus 6, so your expected result will be 19 in decimal. Okay. So you add pair by pair. Okay. So this upper value is actually C in. Okay, all this value is actually C in. Okay. So this is A, A1, A2, A3, A4. This is B1, B2, B3, B4. And then this is your S. Okay, so this is your S. So your S. So 19, when you convert to binary, okay, you will get 1 0 0 1 1. So this is how you perform addition, okay, for multiple bit. Okay, so I give you another example. Okay, for example, you need to add value between 3 plus with 4. Okay, 3 plus 4. Okay, so 3 plus 4 by using 4 bits. So we consider 3 is A, okay, 4 is B. Okay, so your expected result is 7. Okay, so this is S. So because we need to use a 4-bit, so you need to construct or perform the addition by using this format. Okay, by using this format. Okay, so A is 3, in binary will be 0, 0, 1, 1. Okay, B is 4, so in binary will be 1, 0, 1, 0, 0. So when you perform addition, you will get 0, 0, 1, 1 plus 0, 1, 0, 0. Okay, so I will change the color to show you the value. Okay, so 1 plus 0 is 1. Okay, your carry is 0. Okay, 0 plus 1 plus 1, sorry, plus 0, you will get 1. 0. 0 plus 0 plus 1 is 1. 0. Okay, your carry in is 0, so 0 plus 0 plus 0 is 0. Okay, so your answer is 0, 1, 1, 1 or equal to 7. So this is how you perform the addition, okay, by using binary bits. Half adder and full adder circuit. Okay, previously I explained the process of binary addition by using 1 bit or multiple bits. Okay, so now we will look at the circuit that we can use to perform the addition. Okay, first we start with half adder. So this is diagram for half adder circuit. Okay, so this is the diagram. Okay, based on this diagram, it shows that you have two input, okay, A and B, and then two output, S and CO. Okay, so half adder is actually we use to perform the addition that involve only one bit. Okay, so same as the first explanation regarding to the binary addition. So how we can design the circuit, okay, for half adder. So designing the circuit, we need to have 3 steps. Yeah, as you can remember in chapter 3 and also chapter 4. So first step is you need to derive the truth table. Second step, you need to simplify the equation. And the last step, you need to draw the logic circuit. Okay. So we start with the first step, okay, which is truth table. So based on the truth table, okay, you need to list down the combination of input. So because based on the diagram, okay, this diagram, the input, you have two input, A and B. Okay, that's why you have 4 combination of binary, okay, or bits 0 and 1. For output, okay, you have two output, S and CO. So how you can get the value of S and CO? Okay, now we're talking about addition. Okay, we're talking about addition. So the value of S and CO is actually you can get by you add value between input, okay, between A and B for each row. For example, for the first row, okay, for the first row, okay, so 0 plus 0, you will get 0 as your sum, and then you will get 0 for your CO. So this actually follow the format of A plus B, so you will get S and CO. Okay, so you follow this format. So for the next row, also perform the same process. Okay, 0 plus 1, your S is 1, okay, your CO is 0. Okay, and then next 1 plus 0, so your S is 1, your CO is 0. And the last one, 1 plus 1, you will get 0 for your S, and the CO is equal to 1. So next step, you need to simplify the equation. So based on this solution, so it is use the Boolean algebra. Okay? So you need to derive the SOP for each output, and then you need to simplify. So because when we deriving the SOP, for example, for S, this is the SOP. So based on this SOP, it's actually simplified, or you cannot simplify the equation, but you can replace this equation to another equation, which is this one is actually equal to XOR equation. So you need to remember in chapter 2, okay, because XOR we have two method how we can write the equation. And then the last one, CO. So CO is equal to A and B because you only has one output that equal to 1. Okay. So complete second step, you go for the next step, okay, which is draw the logic circuit. So you just draw these two expression, okay, for C, A and B, and then for S is A exclusive with B. Next, okay, we go for full adder circuit. Okay, so when we add larger number or multiple bits, so you cannot use half adder, okay, because half adder only involve 2 bits, meaning that 1 bit for A, 1 bit for B, okay, only 1 bit for each variable. But now when we want to add more than 1 bit, so you need to use another kind of circuit, okay, that we call a full adder circuit. Okay, so you must remember the format of your process of addition, okay, by the addition for 4 bits. So you have 4 bit, okay, A you have 4 bit, A2, A1, and then plus with B also you have 4 bit. And then you add, you will get S1, okay, as your first value, and then next you will get C in. And then here is S2, okay, and then you have C in, S3, C in, okay, S4, and the last one here is C out. Okay. So what means by the 2, 4, and 8 columns at 3 bits, C in, A, and B. Okay. So this is actually referring to this column. Okay, this column. So this is column 2. Okay, this is column 4. Okay, this is column 8. Okay, so where did this value come from? So this actually come from the position of your binary bit. Okay, so if you remember in chapter 1, okay, your binary is actually 2 power of n, right? Yeah, for example, if you have 4 bit, okay, so you start with the first one is actually 2 power of 0, 2 power of 1, 2 power of 2, and 2 power of 3. So this value is actually equal to 8, 4, 2, and 1. So this is where the value of 2, 4, and 8. So you need to add between these values. So that's why the full adder diagram, okay, the input, we need to have 3 input. Okay, we need to have 3 input. Although the first column you only has 2, but for the next column, we need to add the C in value. So that's why, okay, we need to have 3 input for full adder. The output is actually same with the half adder. So how we can construct the full adder circuit? So we need to have 3 steps. Okay, truth table, equation, okay, simplified equation, and the logic circuit. So this truth table, okay, we have 3 variables. Okay, so that's why you have 8 combination of binary 0 and 1. And for your output, you have 2, okay, S and CO. So the value of S and CO comes from the process of addition between each variable. Okay, 0 plus 0 plus 0, you will get 0, and your carry is 0. Okay, another example is this one. Okay, so this. Okay, 0 plus 1 plus 1, so you will get 0, 1. Okay, then this one. Okay, 1 plus 1 plus 1, so you will get 1, 1. Okay, so you need to add. Okay, you need to add each row to get your S and CO. So next step is simplification, okay, of your expression. So this one is actually using the Boolean algebra. Okay, so you write the SOP and then you simplify. So the first step here, okay, is actually factorizing, okay, between these two product term. Okay, so it's factorizing, and then between these two also use the factorizing. So here you factorize a bar, okay, and then here you have a, okay, and then this is the value in the bracket after you factorize the value. Right, so next step, okay, how from this product term or this equation change to this one, or this one change to this one. So if you refer to the equation, okay, b bar and c, okay, plus with b c bar, so this actually follow the format of XOR. Okay, so if we change to XOR, it will become b exclusive with c. Okay, so it's actually same with this one, okay, this one, a bar and b plus a and b bar. Okay, so is equal to a exclusive b, meaning that the first variable must complement, the second is not complement, plus with, okay, now we change, which is the first variable is not complement and the second variable is complement, so that's why it's equal to XOR. So same goes with this one. Okay, so yeah, this one is actually come from the format of XOR, so that's why we replace by using XOR. Okay, why? Because we want to simplify. If not, we need to draw by using different kind of gates. But when we simplify by replacing with this equation, so you only use one gate, which is exclusive OR. So same goes with this one. So this one is actually follow the format of XNOR. Okay, so that's why um, we change, okay, from this equation to this equation. Okay. And the last one, how you can get this equation. Okay. So for the last equation, it's actually based on the previous one. Okay. So if you refer this one, the whole equation, okay. So the whole equation is actually follow the rules of XOR. Same with this one, okay, XOR. Why? So I write down here again, A bar will be XOR with C, okay, plus with A, okay, B XOR with C. Okay, so you know that for your XOR equation, okay, that has have two variable. Okay, so you have the first variable, okay, is B. If you refer to the first one, okay, wait a minute. Okay, so this one, B bar, C bar. Sorry, B bar and C. So here is B and C bar. Okay, so actually this one also follow this format, A bar and with this product term, and then this one is A and with this product term. So this is actually considered as one variable. Okay, B exclusive C is actually replacing C. Okay, B XOR with C is actually replacing the C bar. So that's why this is actually follow the format of XOR. So when we change to XOR, you will get A XOR with, okay, so simply like this, B XOR with C. Okay, because we want to show that you have two variable actually. Okay, but because we use the same sign, that's why we just remove the brackets. Okay, so you will get A XOR B XOR C. Okay, B XOR C. Okay, so same goes with the next one. Also use the Boolean algebra. So factorizing. Okay, and then you get this one factorizing, so you get c bar plus c, so c bar plus c is 1. So 1 times a and b, that's why we get a and b. So here also use the format of XOR, so that's why we replace the XOR. So the last step, you draw the logic circuit. Okay, so you will get this logic circuit. You just follow the equation for S, okay, and also for CO. So this is how we can construct the half adder circuit and also the full adder circuit.